know what just happened with this baking soda and vinegar? I want you to turn around and talk to your partner, talk to your friend, write down what you think just happened between this baking soda and vinegar. Go ahead. Take a couple minutes to do that. Okay, write down what you think happened. So we saw a kind of a eruption. This is baking soda and vinegar. That's what you put in a volcano to pretend like there's an eruption, right? Okay. All right, so hold on to what you wrote, and we will discuss it later, okay? So in today's lesson, you're going to learn what a chemical reaction is, what happens when chemicals react, and you're going to learn to distinguish the difference between acid-base reactions, combustion reactions, and oxidation-reduction reactions. So you're going to learn the difference between acid-base neutralization reactions, excuse me, I messed up the first time, combustion and oxidation-reduction reactions. So you're going to learn how to distinguish these types of reactions by looking at the reactants, the products, and then what happens in the reaction. Okay? So, when given various types of chemical reactions by the end of this lesson, you will learn to categorize the chemical reaction as acid-base neutralization, combustion, or oxidation reduction with hopefully with 80% accuracy. Okay? Okay, so who remembers the difference between a chemical change and a physical change? Jesse? Okay, right. So what exactly happens in a chemical change? So a chemical change occurs when a substance becomes a new substance. I want you to write this down. A chemical change occurs when a substance becomes a new substance through reorganization of the atoms. The new substance has different properties, such as a new freezing point or boiling point. Okay, so knowing what you know now, can anyone give me an example of a chemical change? So try to think of a chemical change that happens in everyday life. You can raise your hand. Luke? Something that... Mentos and Coke, right. It produces a gas. It produces a pretty violent chemical reaction, I believe. Okay, that's one. What about like when we eat? So say we eat a delicious slice of Papa John's pizza, and it enters your stomach, and then what happens? We have gastric juices, including hydrochloric acid, that breaks down the pizza. Now, this is kind of a gross question, can we ever get that pizza back to its original form? No. Of course not. We don't want it back after it's been in our stomach, do we? So when we digest food, that is an example of a chemical change. That food has been taken and turned into another substance. Okay, so what about a physical change? What's a physical change? I believe that would be a chemical change, but change, an example of physical change would be water freezing or water boiling, because the chemical makeup of the H2O has not changed, but it has just changed a form. It's changed in form. It's become ice when it's frozen, and it's boiling, and it becomes steam when it's boiling. Okay, so today, let's go back to this reaction between baking soda and vinegar. So I want you to share with me what occurred, what you think occurred. So now you're going to get out that piece of paper that we did a few minutes ago, and you're going to share what you think happened. So what do you think happened in this reaction? Was it physical? Or?
Chemical.
Right, why do you think it was chemical? What evidence do you have that there was a chemical reaction? So what did you see? They're gone now, but if I mix this up a little bit, some start to form again. What happened? Just explain what happened. Well, a lot of bubbles came up, right? So what do you think those bubbles were? Molecules of something. Yeah, they were gas molecules. They were carbon dioxide gas molecules. So that's how, so if we have that production of a new molecule out of something else, what do you think that's a chemical change? Do you think a chemical reaction occurred if we produced a gas molecule of something else? So we started out with sodium bicarbonate, which is baking soda, and we added acetic acid, which is vinegar, and it reacted and it formed carbon dioxide as a byproduct. So yes, a chemical reaction occurred. So on your desk, you should have a KWL chart, okay? Has anyone ever filled out a KWL chart? Okay, so you know that it's arranged in 3 parts. You're going to fill out what you know, what you want to know, and what you learned, okay? So, this is about chemical reactions, okay? So I want you to jot down a couple of things you already know. Maybe I just told you something about a chemical reaction, and that's okay. So you can fill that in too. So you can add things you already know, and then add a couple of questions about things you want to know, okay? And then we're going to go through the lesson, and I'm going to stop and ask you some questions, and I would like for you to fill in your KWL chart as we go. This is your way of taking notes during the PowerPoint, okay? All right, so take a couple minutes and fill out what you know and what you want to know about the chemical reactions. Okay, so you should be finishing up your KWL charts, okay? I'm interested to hear what some of you wrote and some of you want to know, okay? What you already know and what you want to know about chemical reactions. So how about Tim, will you tell me what you already know? You know that a chemical change happens in a chemical reaction, yes. And how about, what do you want to know? What types of chemical reactions there are? Anyone else? Okay, all right, so listen, we're gonna talk about chemical reactions now, and if you find something that you've learned that's different, that's on your KWL chart, go ahead and fill it in, okay? Okay, so first we need some vocabulary. We're going to go over the chemical reaction vocabulary. So a reactant is a starting substance in a chemical reaction. It appears to the left of the arrow in a chemical equation. The product is a substance resulting from a chemical reaction, and it appears to the right of the arrow in a chemical equation. You must be asking, what is a chemical equation right now? Well, this is what a chemical equation looks like. This is a hypothetical chemical equation. So a chemical equation is a representation of a chemical reaction, and it shows the number of reactants and the number of product molecules, okay? So we have a hypothetical molecule A, B, and C, and do you notice that, what do you notice about A, B, and C? Susan? Okay, yeah. They're all there. They're all still in the products, but what's different? Luke, what's different about the reactants and the products? What's different about the reactants and the products? The order is different. So we have AB here, but we have AC over here. So that means a new substance was formed. But what do you notice about the numbers? We have the same number of each substance, though. So how do you know when a chemical reaction takes place? Well, remember when we reacted baking soda with vinegar, we saw a new substance. And what was that new substance? It was carbon dioxide gas. So we take baking soda, which is also known as sodium bicarbonate. We react it with acetic acid, also known as vinegar. And we get a new substance, sodium acetate. We get water, and we get those carbon dioxide bubbles of gas. Okay, so we knew by looking visually at the reaction that a new substance was formed because of the gas bubbles. Okay? So, again, we know this. We also know this by looking at the chemical equation and seeing that the reactants and the products are different. So how does the law of conservation of matter pertain to chemical reactions? Do you guys remember what the law of conservation of matter is? Luke, can you tell us? Okay. So how about Jason? Can you remind us what is the law of conservation of matter? Yeah, it involves matter being conserved, yes. So what does it state? Let's just remind ourselves. The law of conservation of matter states that matter can go through physical or chemical changes, but matter or mass is neither created or destroyed. So this holds true for chemical reactions, because a chemical equation means an equation, the definition of an equation is both sides are equal. So that's the same for a chemical equation. Both sides should be equal with mass. So with chemical reactions, the molecules react and the atoms in the reaction bond with new atoms to form new molecules. But the number of atoms in the reaction remains the same. So that's how the law of conservation of matter plays into chemical reactions. Here's an example. We have methane gas. Reacts with oxygen in a combustion reaction to form carbon dioxide and water. Well, we're not going to get too much into mole chemistry today, but what I want you to know is that if you count up all the carbons, all the hydrogens, and all the oxygens, it should be equal on both sides, okay? So that's the takeaway I want you to know about the law of conservation of matter today as it pertains to chemical reactions. So what are the types of chemical reactions? That's part of our objective today, is for you to be able to recognize and distinguish between a few different types of chemical reactions. Well, today we're just going to focus on 3 of the very many types of chemical reactions. So today we're going to do acid-base neutralization, oxidation, reduction, and combustion. So jot these down. Even if you didn't put that on your KWL chart about the different types, I want you to write down these 3 types and their characteristics, because you're going to need to know these characteristics to do your assessment, okay? So today we are going to talk about acid-base neutralization reactions. And one of the characteristics is it's acids and base react, and they form the product of water and a salt. Okay? So write that down. Okay? The next one is oxidation reduction reaction. And in an oxidation reduction reaction, electrons are gained by one part of the reaction, and they're lost by another part of the reaction. So that's why it's called reduction and oxidation. That's another lesson that we really dig into those, okay? But today I just want you to know that it usually involves an oxygen transfer or a hydrogen transfer, okay? The third type of reaction is a combustion reaction. You guys have probably heard of combustion reactions. What is a combustion reaction? Paul? Something to do with fire, yeah? It's when, yes, heat is involved in a combustion reaction. It's not always fire though, because we have combustion reactions going on inside our body too, and thankfully there's not fire. Okay, so this involves a fuel such as a hydrocarbon, like a sugar, and oxygen. Okay, heat is produced in the form of energy. Or energy is produced in the form of heat, excuse me. The products are water and carbon dioxide. Okay? So here's an example of an acid-base neutralization reaction. We have hydrochloric acid reacts with sodium hydroxide to form sodium chloride salt and water. Okay, so the main things are the salt and the water when an acid and base react. Then we have an oxidation reduction reaction example. So we have the metal iron reacts with oxygen, probably the oxygen that's in water, or over time the oxygen that's in the air can form iron oxide, which is rust. Okay, so a new substance is formed. Okay, so the last one, the third one, is the combustion reaction. So we have a sugar here, a hydrocarbon, a sugar, and it reacts with oxygen, and our product is carbon dioxide gas and water. All right, so I'm going to randomly call on you guys to classify these 6 reactions, okay? Okay, Kelly, what about this first one? We have sodium hydroxide reacts with nitric acid to form the salt and a water. So what's the key? Salt and a water. Yes, we have an acid-base neutralization reaction. form carbon dioxide and water. Would this be acid-base neutralization, combustion, or oxidation reduction? It would be combustion. All right, so what about magnesium hydroxide reacts with hydrochloric acid to form the salt magnesium chloride and water? Tim? Right, so salt and water was formed, so it's an acid-base neutralization reaction. All right, here we have another hydrocarbon reacting with oxygen to give us carbon dioxide and water. What is our key there? What type of reaction is this? Kyle? Yes, combustion. Combustion. Okay, Susan, we have the metal, aluminum, reacts with oxygen and forms aluminum oxide. What would that be? We would have that's a combustion reaction. It's also an oxidation reduction reaction, but combustion reactions are oxidation reduction reactions. I don't want you guys to get too confused with that. Okay, so we have one more, and Lisa, I want you to tell me if this copper 2 oxide reacts with hydrogen to give us copper metal and water. Can you tell us what type of reaction that is? Hydrogen's involved, so yes, it would be oxidation reduction. Okay, so any questions so far? All right, so that was our guided practice. Now I want you to try these by yourself, okay? So I want you to take your whiteboards out, and I want you to look at these reactions and classify these according to the 3 different reactions we talked about, which were acid-base neutralization, combustion, and oxidation reduction. So I want you to write one of those 3 words on your whiteboard, and I want you to number your whiteboard 1 to 7 because there's 1, 2, 3, 4, 5, 6, 7. So I highlighted every other one so that you can tell, so you don't get confused. There's 7 reactions. Label your whiteboards 1 to 7, and I'm going to walk around and check for understanding. Okay? Okay. So you should be done categorizing the chemical reactions. So these, I checked your answers, but these are your answers. The first one was oxidation reduction. The second one was acid-base neutralization. The third one, combustion. The fourth, combustion. And the fifth, acid-base neutralization. The sixth was oxidation reduction. And the seventh was acid-base neutralization. Okay, so for the summative assessment, I have set up stations in the back of the room. There are 5 stations, and each one has maybe an item on it or a couple of items on it. One has some models set up as a reaction. I'm going to ask you to take a piece of paper and a pencil to the back of the room, and you're going to number your paper. Make sure you put your heading on your paper, number your paper 1 through 5, and you're going to categorize each numbered station as oxidation reduction, acid-base neutralization, or combustion, just like you just did with the PowerPoint on your whiteboards, okay? But this time it's going to be a little different. You're going to have some items, you're going to have a reaction, so you need to figure out the type of reaction based on what clue you're given, okay? All right, let's I want the first row to go ahead and go. I just want to go over what we did today, just a recap. So we talked about chemical changes, and the chemical changes in substances are also known as, yes, chemical reactions. Chemical reactions can be written in equation form, and they show the changes in reactants and products. Chemical reactions can also be classified, and that's what we just did. We categorized the different reactions into their categories. And those types of reactions today we went over were combustion, oxidation, reduction, and acid-base neutralization. Okay? So again, how do we classify changes in the substances? How do we classify changes in substances? Kyle. We classify them through chemical reactions and the types of reactions. How can we relate the law of conservation of matter to chemical reactions? Jason. Because in a chemical reaction, the mass on both sides remains equal. We may change the substance, but we don't lose a total mass. The total mass on each side of the reaction stays the same. So what do we look at in a chemical reaction to determine how to classify it? We look at the reactants, the products, and what happens in the chemical reaction. All right, so I hope that you learned a lot about chemical reactions in this introductory lesson. I want you all to have a happy and safe weekend.